Derivatives are a fundamental concept in calculus. A derivative measures the change in a function, otherwise known as the slope. We used to compute the slope on linear lines using this formula, y equals mx plus b, and m would be the slope of that line. But when we're working with more complicated functions, such as y equal to x squared, the basic quadratic function, you can also write it as f of x is equal to x squared. And to find the slope of this function, we have to use calculus. Specifically, we have to use the power rule. This rule can be applied to any polynomial function. So if we have f of x is equal to x to the n, and then f prime of x, which is the notation for a derivative. So the derivative of x to the n is going to be of the form n times x to the n minus 1. So if we look at our function right here, f prime of x is going to be 2x. And that's the slope function for x squared. And so if we were to look at, say, point 0, 0, the slope of this point right here would be 0, horizontal line. And this line is called the tangent line because it touches the function, this function right here, at exactly 1 point, 0, 0, right? If we were to take another point, for example, 1, 1, which is on this line, right? It's right here, approximately. So first, we'd find out what m is. So m is the slope. So we'd use this function over here, 2 times the x value, which is 1, which is 2. So that's m. And then y is 1. So 1 is equal to 2 times 1 plus b, and that gives us b is equal to minus 1. And so the tangent line at point 1, 1 would get us y is equal to 2x minus 1. And we can see that lines up, so approximately here. Draw the line, and that's the tangent line at point 1, 1. Okay, another example using power rule. We had a function that was, let's say, 5x to the cubed plus 4x minus 7. Well, f prime of x, the derivative, would be 5 times 3, 15, x squared, plus 4, right? Because it would be 1 times 4, and then the exponent would be 0, so just be 4. And then minus 7, whenever you have a constant, you just ignore that term. And so that would be the derivative of that function. Some other rules we have is something called the product rule, which is this formula right here. If you have two functions, say f of x and g of x, well, the derivative of this product is going to be f prime of x times g of x plus f of x g prime of x. So say f of x is equal to 2x squared, and g of x is equal to 3x cubed minus 4. Well, then it would be, so the derivative of f of x times g of x would be, so let's calculate the derivative first. So it would be 4x, and g prime of x would be 27x cubed. And then we just plug it into the formula. So it would be 4x times 3x cubed minus 4 plus 2x squared times 27x squared. And then you can simplify terms. The last important rule, there's more, but these are the fundamental ones, is called quotient rule. And this is f of x over g of x. The derivative of that would be g of x f prime of x minus f of x g prime of x over g of x squared. And then you can compute that similarly to the example in the product rule. And then lastly, there's some different notations you can use for a derivative. You may also see dy over dx, which is change in y over change in x. And there's some special formulas that you have to remember for certain functions. For example, if we had d dx of, and then y is e of x, e to the x, usually seen in this notation. So the derivative of e to the x is just e to the x. And then if we have ln x, this would be 1 over x. So these are just special functions. You just have to memorize these. And then we have the trigonometric functions. So if we have sine x, the derivative is cosine of x. And then with cosine of x, we have minus sine x. And lastly, for tangent x, we have secant squared of x.